Thank everybody for being here today. I'd like to thank Sarah for hosting this fantastic conference. This is my first conference with Sarah, and so far it's been very enjoyable. Also like to thank Bob for who's not in here at the moment, but he's put in a lot of work in the field. He's kept everybody together, kept everything running pretty well. So he definitely deserves a round of applause there. We do also have, I'm sorry, what was your name again?
Mark.
Mark. We have Mark, who's a student here, physics student, or computer science student here at the University of Texas, Dallas. We met him yesterday during the eclipse. He was set up with his camera, talked a lot about, saw that ARRL hat on him, and so that kind of got these people's attentions. So he's joining us today because he has an interest in radio astronomy. And hopefully this presentation provides the basis, the start of what he needs to get started, because that's really the point of this discussion today. So the Novice's Guide to Amateur Radio Astronomy. So when just a little background, I studied some physics and astronomy in college and then switched to mechanical engineering, but I always kept my love of astronomy, especially radio astronomy. And so then when I got kids grown up and out of the house, I started getting back into it. And so this is kind of a summation of what I've learned as being, I have a little bit of knowledge, but I don't have a whole lot of knowledge on the process. And so I've been learning over the last year and a half, mostly thanks to the people in this room and on the SARA webpage, in discussion groups as well. So first we'll get into this is just an outline of what we'll do, of what we'll talk about today. So why do radio astronomy versus visual astronomy, and why do radio astronomy at all, and how to get started. What areas do you want to get? What areas are available for you to learn in, and what do you want to get started in? What do you want to learn more of? Some things to be cognizant of, things to pay attention to when you do get started, and then some just basic steps afterwards. So first, this is an intellectual rabbit hole for almost all of us here. Once you start in radio astronomy, you never stop learning because there's so much to do, and it is such a new science, relatively speaking, especially with optical astronomy. But it is a great hobby, and it can be a great profession if you even get into it there. So some of the benefits, it's fun, it's challenging, it's rewarding. Most of us have gotten here because of our own research. We've been doing our own projects. We want to do more radio astronomy, and this is going to tell you why you would want to do it, what to expect, and how to get started. So my real goal in this is to encourage more novices, more amateurs into the field, so that they can become wannabe astronomers as well, which is definitely where I fall into. This initial talk, almost everyone here has capabilities far beyond what the technical aspects of what this is going to talk about. So this is really going to be talking about what to keep in mind when talking to amateurs, people new to the science, and how to help them get started. What this will not be, it will not be a treatise into what radio astronomy is, how it was developed, the whole history behind it. Trust me, there's a lot of information, and that will far exceed my 45-minute time slot today. So why do radio astronomy versus visual astronomy? And who are, I guess when I start in with that, what is the average amateur astronomer today? Mostly male, I'm assuming, mostly over 35, probably have a family starting to get a little bit older. You don't have to give them as much attention, and they are technically and scientifically curious and capable. Most of you proved that out very well with your ham radio experience, antenna building experience, microwave backgrounds. What do a lot of these new astronomers, these 35-year-olds with 2 or 3 kids, not have a lot of? It's probably the same things most of us don't have enough of: time, money, and access to quiet, dark skies. This is where really kind of where radio astronomy can really help those people who want to do astronomy, get started in. So first on the cost, depending on your project, you can get started for under $100 USD. You can do serious work in hydrogen, in the neutral hydrogen band for less than $300. You can get started in it for under 100. You can do good work for under $300. Projects do not scale in cost or complexity in a linear fashion, right? The big you go twice as big, it gets probably about 10 times more expensive, and you're just going to see that exponential growth. So this is where it really benefits the amateur radio astronomer to stay small and to work within your constraints. And a lot of the stuff that it takes to do these types of projects, you already probably have a lot of this stuff in your home, in your local hardware store, or access to it somewhere else. So some of the example projects that are already out there. So Radio Jove, this is listening to radio waves produced between the volcanic eruptions of Io into the, I think it's Io, and it's into Jupiter, and that produces these radio waves. You can buy the basic kit for $95. You can buy the kit, the receiver, the software, everything ready for you to go for $384 per my latest calculation. Super SIDS, this is a sudden ionic disturbances. This is a basic loop antenna with this $48 receiver, and you're able to listen to VLF stations as they bounce off the ionosphere, and then you're able to see how the height or the density of that ionosphere disappearing, and then a lot of that is coming from the CMEs from solar events themselves. Scope in a box. This is a very popular one. This $350 kit is provided by SARA right now. This is a grid antenna with a receiver, with a feed, and everything you need to get started. It comes with the SDR, I believe, as well. And so it's got everything you need to get started to start doing neutral hydrogen studies, galactic neutral hydrogen. And of course, you don't even have to start there. Where I started, this was my first pyramid horn antenna that I built using the aluminized foam from a hardware store. And so this is basically my cost right here. I was able to purchase everything, including the computer, for under $200 to start measuring hydrogen in the galaxy. So to keep up with the Y radio versus visual, time and dark skies. You can perform radio astronomy anytime, day or night, in almost any weather. One of the great benefits of radio astronomy. Once you get a system up and running, especially if you're doing drift scans in hydrogen or Radio Jove, you set it up and it will run 24/7. You don't have to babysit it. You don't have to stay up in the middle of the night and change settings. You don't have to reposition it or anything like that. My first project ran for 6 months unattended. I just pulled data every day, did some pre-processing to make sure nothing went haywire, and then collected all this data and would go out once a week and adjust the angles so that I'm getting different parts of the sky. Plus, radio astronomy is cool, right? It's something dads around the world need help with, I'm sure. But of course, your children, if they're seeing you, especially if you are what I'm going to say, the typical new amateur astronomer, 35, 40 years old with a family, your children will probably see this and they will see you doing this and they may get interested in the hobby too. So now you're getting younger and younger people interested in this. And plus you're going to make a lot of new friends with your neighbors, because mine asked me, hey, what is that alien catcher doing out there in your yard? Is that a solar oven or something? I've had all kinds of questions. But you get to explain some of this. It gives you kind of a minor outreach. More people in my neighborhood now know a little bit more about radio astronomy. And then I learned that there's actually a Western Kentucky University professor of physics who lives in our neighborhood. So now I didn't know that until somebody said, "Oh, this is for astronomy. There's a physics professor over here." So now I have a new contact that I can work with as well. And you may not be trying to catch aliens, maybe. Um, Plus, there are some unique opportunities in radio astronomy. For me, it's easier to analyze what is happening, not just what you are seeing, but what is actually happening. Because of the nature of radio frequencies, radio waves, you can see how things are moving, if they're moving away from you, the Doppler shifts. Um, it's fundamentally the same as visual astronomy while being fundamentally different. And this is really great because we've talked a lot recently about combining those visual images and the radio. We saw that with Dr. King yesterday, uh, merging those radio and visual images to get a more complete picture. And then you start throwing in ultraviolet or anything else, and you can get a much more complete picture of what's actually happening out there in space. It's easier to watch space weather from a radio perspective, which is an important part of our current history, our safety. We had a very nice discussion with Dr. Fabiano this morning and learned that, as we're reaching solar maximum, the time for orbital drag is decreasing by like 200% or something. It went from like 2 years to 10 months, so this is important implications for all those satellites, the space junk, the retired satellites that are up in space. And plus, and well, I just already said that, combining all the spectrums to really understand what's going on in our universe. Now, from the hardware perspective, it can be as complicated or as simple as you want. I'm still working with very simple grid antennas with very simple waveguides. Some people here are working with 3-5 meter satellite dishes. Bob's probably got as much as NASA's got set up on his ranch out there in Texas. But most of this can easily be built and set up in your home as long as you take in the space consideration, your limits, what you're actually capable of seeing in your field of view. But of course, it's always evolving. 20 years ago, we didn't have access to these little satellite dishes for digital cable from space. And now people throw those away like left and right. And now we have members using those to study masers and things of this nature. So there's reintroducing that equipment for scientific purposes. It's endless designs and tuning and testing. If you're into hardware, this is a great place. If you're into antennas, this is a fantastic hobby. I would say, from my experience, probably a good 75% of SARA members are really focused on the hardware, which is very, very important because you need to have you got to be able to trust your hardware to tell you that you're taking believable measurements. And so we feed off of each other. I didn't know anything about hardware until I joined SARA. I've learned everything from this group. And so, and plus you can, like I said, the good data that goes hand in hand with the good hardware. So on to the software portion of it. 30, 20 years ago, there was not a lot of options when it came to software. Most of your software you had to do yourself. If you were even capable of doing the software, some people still recorded on line charts. But now the amount of software that's actually ready to go is increasing at an ever increasing rate. And most of those people that are developing it are in this group as well. Ezra from Ted Klein, supposed to be easy RA, haha, because RA is not easy by any stretch, but it's very good for hydrogen line research. SDR Sharp has very good plugins. Virgo, also very good for drift scans. And DSPIRA from the West Virginia University group, they have many new radio programs set up with the plugins to talk to your SDRs, to plot this data, to do calibrations, whatever you may have it. So there is already good software out there. So now it's much easier if you're into the software side of life to get started. But of course, if you like creating software, if you like improving software, if you like trying to do new things with it, this is also another fantastic hobby to get involved with. It's not just hardware. The software is just as important as the hardware portion of it there. So electronics. Um, Historically speaking, radio astronomers, radio astronomy was developed by electronics experts, these people that had experience with electronics or with radio. And it started with very, very highly skilled amateurs and professionals who did this on as a hobby as well. But with this usage of highly of with this ever increasing amount of experts developing the software and this hardware, that the electronics have gotten smaller and smaller and smaller. Up here in the right, that was like a typical radio astronomy room there. It was a room full of equipment that it took to move, control, and record the information. And now you can do it for less than $100 with a software defined radio and a decent low noise amplifier. So it has reduced the amount, the quantity of electronics that you need to purchase to get started in this. So I think some people, when they think about radio astronomer, they're thinking like Contact, right? They think of the movie Contact, they think of the big dishes, the big rooms, they've got all this equipment and sci-fi stuff going on and everything, when really it's getting down to these two pieces of software, I mean, two pieces of hardware plus a laptop or a Raspberry Pi or something of that nature. So it's the entry is much easier than it used to be. So for the science portion of radio astronomy, so like I said earlier, it's easier to, at least for me, it's easier to analyze what is occurring and by how much than other forms of astronomy. We saw yesterday with Rob's setup to do, if you wanted to see the spectrum, you had to have special hardware to see that spectrum. With radio astronomy, you don't necessarily have to have that. You have to have the hardware to receive that in there, but then you can process that data to get to see the spectrum, to see how much red shift or blue shift you may be seeing, how much total power from a source, which then allows you to get into doing hydrogen galactic analysis. You can now calculate the rotational velocity of the galaxy. That's where you can see that their Keplerian motion fails past planetary distances. It gets into to the missing matter, dark matter. But then you can also get into spectroscopy, masars, quasars, all the way up into fast radio burst. And we have many members here who we have members here who are doing a lot of research in pulsars and fast radio bursts. But that equipment, that's where you're really starting to spend the big bucks. So if you've got the money, please spend it and become an expert at fast radio burst. But fast radio burst equipment's expensive. It doesn't, even for the pros. So how to get started. Some people just want to see stuff. A lot of people buy telescopes because they just want to see stars. They want to see planets. That's cool. If that's what you want to do, you can look in your closet. You'll probably find old computers. They don't have to be super powerful. If they've got a USB port, they're probably good enough to do what you want to do. But if not, you can, a lot of us work in places where they're constantly turning over computers. We're replacing stuff. So they're throwing away stuff. You can find stuff for a dime a dozen in your local marketplace. You don't want to spend a lot of money getting started, because you may get into this hobby and say, this isn't really what I thought it was going to be. I don't want to be out $1,000 and then trying to recoup that somewhere later when you got a bunch of cheap astronomers who want to buy it for a dime a dozen. But for the money, stay with SDRs as much as possible, just because the barrier, the knowledge barrier to the entry is lowered so much. Mostly because of the software that's already freely available. You're not having to pay to buy a special Microsoft version of it. You can check GitHub, you can check our web pages. Everybody's got their favorite software they use. It's all open source for the most part. It's all freely available, and you can get started. Like I said, very budget equipment, very budget software, and you can find out if this is something that is really something that you want to do. I am a big fan of Raspberry Pis. Some people are not. I use nothing but Raspberry Pis for all my data collection. I have other desktops that I do for the heavy processing of the data, but all my data collection, it's so simple these days with SDRs that literally you can do it with an old Raspberry Pi 3, some zeros or something like that. Now, once you get into doing this radio astronomy, you may find that you want to do more than just collect data. So this is where I suggest, and we hit on this a little bit yesterday, find your specialty. Find it what it is that you want to do and get very, very, very good at it. Whether that's hardware, software, the math, the physics, whatever it may be. But of course, don't just limit yourself. Don't just focus on that one item, because then you're going to start missing more of the bigger pictures, because it's really great to understand the software side of it. But if you don't understand not exactly, if you don't have a good understanding of of what that hardware is actually capable of seeing, you may be writing software that's not feasible for your application. So you want to keep a good overall picture, but find something that really interests you. If you do get serious, you should consider deeper study in all these categories, because like I said, that makes you a more complete astronomer, and you have a lifetime to learn, because there's so much to learn. And along the way, you're not going to know most of anything. You may know a lot, but you probably won't know most of everything. So there are experts in your field. There are experts in your subject matter, and a lot of them are in this room. A lot of them are online today. SARA, there are many great resources, mentorships, the listserv, the boards, emails, phones, whatever. Everybody loves helping everybody else, seeing everybody succeed. So please ask those questions. There's not a bad question. Maybe a bad answer or two, but there's definitely not a bad question. So like I said earlier, SARA has a lot of resources already freely available. A lot of people use what we call the listserv, which is Google Groups now. It's not really a listserv anymore. But and that's where we can really ask personal questions and let individuals answer on like a message board. But there are several really great sections on the SARA website. Like you can see here, the analytical section, electronics, outreach. Go and review these sections. They do a good job of keeping these updated, and review this material in here. What I got interested in was doing the analytical part of radio astronomy. And through this, I was able to make contacts with Steve Zickas. Now I'm collecting data using the 20-meter telescope in Green Bank.
And by the way, the SARA website is radio-astronomy.org.
Yep. And so like Ed said, it's a radio-astronomy.org. Each section has a coordinator. If you contact them and ask them any questions, trust me, they will be delighted to answer any questions you may have. There's also the education section on the SARA webpage, which has a very good introduction to radio astronomy, also how to get started, and some of those teacher projects. We also do grants through SARA for different projects, and we have a YouTube presence on there now. for the Society of Amateur Radio Astronomy. This presentation will be up there. We have many videos going through different portions, all of our R-tops. So those are our observational parties. We do those on a regular basis. Those are stored on YouTube. The conference material, special videos on math, physics, programming, whatever it may be. It's all up on the
And there's
on
also
YouTube.
2 per month. There's 2 per month, Zoom sessions.
What three? Well, I guess if you count you have the Drake's Lounge. We have Drake's Lounge Australia, because we have a
Oh, I
large
forgot
contingent in
Australia.
Australia. And so we want to make sure that we get
That's
the
3.
other side of the planet on there. And then those are more focused on the engineering aspects. And then the R top is the observational party. So focused on what are you seeing? What are your new findings? What are your observations that you've seen out there? All very, very good resources to use. Another important aspect, which may seem kind of trivial at first because it seems like a life detail more than an astronomy one, but especially when you're doing science, especially when you're doing radio astronomy, pay attention to the details. You have to check, double check, triple check, and patience. If you get impatient, you will start making mistakes. You will overlook a part of your circuit or your something, and you may trust, oh, I've nailed it, and then somebody else can come behind and say, well, actually, this was my measurement and it doesn't match yours. And so then you find, oh, I didn't carry the one or something, something simple. So detail and check, triple check. Antennas are part of an electrical circuit. I learned this the hard way. You have to keep that in mind, that grounding, you have to make sure your equipment is grounded, just like an electrical circuit. Quickly, when I built my first pyramid horn, I went to the Lowe's local hardware store, got the aluminized, said it was aluminized, nice and shiny, built everything up. I got nothing, absolutely nothing. I got garbage coming out of it. Went and put my probes on it, and it was not conductive. It was just mylar. It's just a silverized mylar, no conductivity whatsoever. I coated everything in aluminum foil, and it worked great. So then when I went shopping for my second pyramid horn, I took a little LED, a battery, and a resistor taped together, and I was pushing it, touching all the fiberboard and everything just to make, or the insulation board, just to make sure that it was actually conductive. And sometimes, a lot of times, you're going to hear, oh, that's not going to work, or oh, that's not the best way. Most astronomers are kind of hard-headed, and we'll just go ahead and do it anyways. And sometimes you learn that, yeah, they were definitely right. That was not the right thing to do. But sometimes you learn that maybe I'm onto something. Maybe this is actually working. Experience is a really good teacher. If you make a mistake, you're going to learn from it a lot quicker than somebody telling you. But you also do have to realize that a lot of these people have 20, 30, 50 years of experience in some of this too. So it's a balance. And like I said, patience, 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 as the mother tiger learned. Uh, a big aspect of radio astronomy that, at least for me, is the science portion of it. This is why we do radio astronomy. This is why you do radio astronomy. This is why I do radio astronomy. We want to learn more about the universe. We want to learn more about our place in the universe, what is happening in our galaxy and outside that we can't physically see and touch. You will benefit greatly from learning as much as you can about the electromagnetic spectrum, Maxwell's equations, how these propagate, how the different parts of the spectrum work, coordinate systems, learning how to convert between coordinate systems, because like I have to switch between RA and I have to switch between azimuth and elevation to galactic coordinates all the time. huge learning curve for me trying to do all those conversions. So there are a lot of basics in astronomy from the physical side of life that are also going to carry over because we are still all looking from the same planet to the same sky. We may be looking in a different spectrum, but we're all looking in the same direction. So there's that basic science portion of it that you really got to get a good handle on. And from there, you can really learn how to apply those physics and the fundamental theorems to what you observe. If you understand the basics of the physics, then you're able to now make some educated assumptions and maybe even a good observation to back up a theorem. Maybe you can apply this to future learning, or maybe you can even apply it to what a professional is trying to do with larger equipment. Hey, I've seen this. Maybe want to look in this direction. One thing that amateurs have to keep in mind is you have to make the studies fit your constraints. I live on 0.2 acres in the suburbs, so a radio Jove with those meter long dipoles are not going to work for me. You may not have $300 to spend on a box, on an out of the box scope. So, of course, scrounge, collect pieces as you can. You may have a nasty HOA, or maybe you live near a roaming horde of antenna eaters like this poor soul. And you have to keep in mind that you have to protect this equipment from the elements, and sometimes those elements have teeth. Find out what's possible with your current set of constraints and get really good at it. I'm not moving it away from my neighborhood anytime soon, so I'm going to stay with small stuff that's not as affected by RFI, and where I have good access to the sky. But if you have a ranch, if you have a farm, if you have the space, by all means, use longer dipoles, set up lower wavelength equipment. You don't even need to have a telescope to do radio astronomy. There is a ton of data already out there. And we will send out, I think this has links in it as well when this presentation goes out. There's a lot of data sitting out there that you can freely collect, and you can start analyzing, you can start processing and learning the data analysis portion of it there to learn to see what the radio is telling you, what the radio spectrum is telling you. Of course, never be afraid to ask questions. We all, everyone here is pretty like-minded. We have different backgrounds, we have different philosophies, but we all are very like-minded. Science, physics, astronomy, experience, like I said, will range far and wide, 0 years, 50 years. Some people have no programming, and some people can whip out. Some people still program in Fortran, as crazy as that may seem. A question is not asked is a wasted opportunity to learn. So definitely ask as many questions as you can. Sometimes I ask so many questions, I feel like I'm being overbearing, but I feel like if I'm not a little overbearing, I'm not going to learn anything. If you stay interested in radio astronomy, you won't really have a choice but to learn, because there's always something new to learn. As one of the first talks I heard Wolfgang give, you have to think like a scientist. Just because you're an amateur astronomer doesn't mean we do things in an amateur way. We're amateur astronomers doing things in a professional manner. So learn to plan a study, test your theories, analyze the data, and update your theories. And I know from my for me, notes are extremely important. I have to document everything or I will forget it. And I rely on my notes just as much as I rely on the SARA members themselves. And so with the last few minutes I have available, one of the things that this has been leading me towards, and there's been discussions in the SARA groups lately about how can we help more? How can we get amateurs and students more interested. What can SARA do to help get people off the ground? We do a lot of projects. The thing that I struggle with as a new radio astronomer is that there is no one source. I can, if you want to get started in visual astronomy, you can pretty much just take one book and go from like zero to hero with just one book in visual astronomy. That doesn't exist because in radio astronomy, just because radio astronomy is only 60, 70 years old as a science. So one of the things that I would like to encourage the SARA group to start thinking of, and what can we do for creating that one source of material? We talked on on one of our last Drake's Lounge Australia's about lesson plans for grade 10 through 12 students, because these teachers don't have time to learn the science themselves. They need it there in a lesson plan with the steps, how to do that. But also these people who have jobs now and are coming into this as a hobby, we need uh, those same types of resources as well. So I would really like to, as a SARA group member, I would like to encourage everyone to start thinking about how can we contribute to the larger scientific community by creating um, a more easily readable resource, so we can go from zero to mildly hero, at least. You know, we don't have to get started, but maybe uh, whether that's a book, a website, series of YouTube videos, whatever it may be. How can we encourage these new people to get started, and how can we make sure that they're successful? Because it's easy to get started and fail, especially when you're learning everything on your own. And my last slide, I would like to thank, like I said, I'd like to thank SARA. I'd like to thank you all for listening. All you wannabe astronomers out there, just like me. It's easily doable for $300 or less. You can build this in your garage, on your patio. You can build it in your apartment. There's lots of off-the-shelf stuff ready to go out there. Radio astronomy is really kind of at this cusp where it can really boom if we push it in the right direction. And the stuff is out there. So I encourage all radio astronomy amateurs to get started with this off-the-shelf stuff, and hopefully encourage more people to learn about the joys to be had with radio astronomy. Any questions?
Comment for yesterday when a bunch of us were set up outside there. We probably should have had everybody that was out there should have had a little stack of SARA literature. And I'm trying to tell people, it's radio-astronomy.org, hoping people remember that, you know. So in the future, that's something we do need to plan for. Is grab a hold of those interested students and make sure they can find our website.
Maybe it makes sense if we had like a standard operating procedure for when we do conferences, especially, okay, you're at a university, we want to have this if we have this document ready, we just print a bunch of them off and take them with you, just like a little checklist.
There is a brochure, which I forgot to include in the proceedings, which basically outlines the fundamentals of SARA, and people should have access to that. Unfortunately, I didn't publicize that, but it's in the radio astronomy bi-monthly journal a lot. So that's a very important resource, is the Journal of the Radio Astronomy of SARA, every 2 months or so. Rich edits it. So that's something you should really look into.